So, if you're still alive and you feel like you can ingest some more information, we'll start digging a little bit deeper. I think Armando gave a really good introduction into active record, and I'm going to go into active record a little bit more here and try to dig deep. Just go a little bit more into the advanced model relations, which are basically how to join one table to another. And if everybody knows SQL, you'll know your basic relational theory. So hopefully you'll be able to follow along. If not, I can dive into that a little bit further. So I'm just going to do a little bit of review. And hopefully people have remembered pretty much what's gone on. We're going to go into some of the conventions again, just to make sure we all get the conventions. And then I'll go into some associations, and then somebody mentioned transactions before. We will be talking about transactions, and then there's a little bit of advanced stuff, like counters, locking, single table inheritance, all that kind of fun thing. And we'll be going into that as well. Sorry? Oh, come on. Okay. The model. We already saw a lot of this, so I'll try to go through it quickly. Basically, the model handles all your persistence. And as Armando pointed out, you need to place all your validations. He gave you all the validates overview. I'm not going to go into it, but I'll just give you a reminder that you want to put all that stuff in your model. And there's some good reason for it. I was talking to somebody in the back. I think one thing that sort of struck home is when you do your testing, you can do unit testing. And you put your validations inside of your model. You can test your models independently of the rest of your application without having to do any kind of fancy work. So if I want to make sure that my model is behaving correctly and that my values are saving correctly, it's good to have those validations in there. And then my controller will behave correctly, and everything else will kind of fall out of it. So please, stick to that. You can actually do your validations if you really wanted to in your controller. It is highly discouraged, and you have to write your own code. So there's no helpers for that. Also, all your business logic. Try not to do your business logic in your controller or in your view. This is somewhat different than PHP, where basically everything is done sort of intermingled. It's really a good idea to put everything that has to do with if you have, let's say, an accounting system and you want to do calculations of withdrawals and deposits and so forth, you want to stick those in your model as well. And you want to keep your view in your controller as clean as possible. Try to keep this logic out of there. Try to make your controller simply for handling your workflow. Have your views for just rendering. And the other thing is be conventional. Don't buck the conventions if you can possibly avoid it. Unless you're using a legacy database and you're trying to integrate with it, which I am doing now with somebody, try not to do it. Because if you name your tables a plural of the class and you use you make your foreign key columns with the class name, singular form, underscore ID, and you use you create your join tables using the alphabetical name of the first class to the second class, or first table to the second table. It makes it very, very easy. Everything is just kind of done for you, and you'll see there's very little code you have to write. The other thing is use migrations. If you want to write all your create statements in SQL, you can do that. I wouldn't suggest it. The creations have nice schema versioning capabilities, which Armando showed you. I'll show you a little bit more of that. I'll also show you how to write the migrations. And it keeps that little schema ID in your database, which will allow you to be able to deploy. And if you deploy _with_ migrations, magically, it will first migrate your database and then deploy your application and then restart everything, and it will just kind of work. You can also deploy to another environment, in which case you could do staging and then production. And it will automatically version all your databases if you have multiple databases like you're doing replication. And the schema will be magically in the right format, and your life will be very pleasant. So let's go through it. So basically, with the associations, I give you some powerful meta-programming, some little keywords that you can use to be able to express all these different types of relationships. They support one-to-one, one-to-many. Many-to-many, you have two different types of many-to-many relationships. You have one that uses a simple join table, which is just a pair of IDs, no ID column, and then there's what's called a join model. The join model has additional data on top of just the relationship between the two tables, and you can do a lot more with it. I'll show you that as well. And it's called has many through. So let's go through a simple model first, and now we start getting into a little bit of the code. I'm going to create a simple little model, which is represented right here, where I have an author. I have some books. I have the author ID here, which refers back to the author table. And I'm going to create this thing using this migration right here. So, create authors, and it's going to create two tables. And you see that there's a name. I put a column created at, and then I have another table called books with an author ID, title, ISBN, and some sales. You can also provide optional things like precision, the limit. If I wanted to make this just like a varchar 64 or a 64 max length string, I can do that. Precision is decimal precision, number of digits before decimal point. Then I can put a scale on there as well. I can also put default values in there as well, like :default 0. This will zero the sale, make the sale 0. So then I can just kind of add to them if I need to. As well, as we alluded to, you want to be able to put the down. So this is going to drop both of these tables. So if I want to revert out this change, I want to get rid of this migration, I can actually just drop both of these tables as well. That's what the down does. It always reverses all the operations you did. Some operations are impossible or so complex to reverse that there's no going back. Most of the time, you want to be able to make it give yourself the ability to go back and reverse out your schema changes. Now we're going to create the model classes. And I think I'm not going to go into actually the code, too much of the code, but basically this is all you have to do. So in the class author, I want to show you something here. We have a has many. We have many books. The foreign key for this thing is the author ID. The class name is book. And this guy, the book, belongs to an author, and the foreign key is author ID, and the class name is author. And it's, again, this relationship. You belong to a single author, and you have many books. It will figure out. It knows the table names are plurals of the class name. So the class names are always singular. The table names are always plural. Oh, yeah. Sorry, my picture. Yeah, it wasn't generated. But because we have conventions, basically, and I've followed the conventions, I can just say this. Has many books, belongs to author. Now, if I create an author like this, basically, it's going to create a new author object. If you look at the actual persistent values are stored in a thing called attributes. Remember we said that the columns for the database aren't actually stored within as instance variables in the object? Well, they're not. They're actually stored in something called attributes, attributes, and it's a hash of all the column names to the actual values for those columns. And that's how it's kept. That's also why when you do something like self.name equals, it's actually assigning to this thing underneath the covers, doing some magic to be able to get it into the right type. So we can create an author. And then we can also create some books. So we can do author.books. Now, books is automatically created from the has many relationship. It looks a lot like an array of books, but it has a whole bunch. It's actually it's a weird proxy object that behaves kind of like an array, kind of like an association. So you have a whole bunch of methods on top of books. So one of them is books.create, and you can specify the title here, ISBN. What's nice about this is that this is going to automatically create a new book object that's going to have the relations back to the author. So that's all going to be filled in for you. So you don't have to do any extra work, just basically create. You can also build an object that basically gives you a new object but doesn't save the object for you. Create creates an object, which means it instantiates it and then saves it in the database in one step.
The create is transactional then?
Yeah. Whereas build is not, new is not, save is. Transactional, if you mean that, do we put a whole, there's a transaction context that's around create. You can put a transaction around multiple steps as well, and I'll show you how to do that in a few minutes. And there's actually some really cool stuff that Active Record gives you to be able to do that. So you may say, okay, great, you got a little model there, but in reality, books can have multiple authors, and authors can write multiple books, and there's no reason that we have to have this one-to-many relationship, so that's all wrong. I agree. So let's do the simple change to this thing, and let's use what's called a has and belongs to many relationship. And this is has and belongs to many is right here. And again, we have just these two changes where I change has and belongs to many there and has and belong to many there. And we get this relationship right here where we get, again, I still screwed this up, but basically this would be authors and authors' books and then books if we're talking about the tables. And then you get this join table in the middle. This join table does not have an ID. It's a pure, it's a join table that just has the two IDs of the other guys, and you index on those. To create this guy, here's the, here's the migration. Basically, create table, authors, books. This ID false means that you're not going to create the ID column. As we said, you can always get around the convention, so this is one thing you can do is get rid of the ID column. As well, we no longer need this thing, so remove column, books, author ID. We no longer need the author ID in there. To reverse this out, we need to drop the author's book table, and we need to add the column back in there for the author ID. Yes, if you wanted to migrate the data, you would have to put some SQL in there. I'll show you how to do a data migration in the next example that I give of migrations. So that just basically creates this has and belongs to many relationship. So we got rid of the one-to-one or one-to-many, and now we have a nice many-to-many relationship. So how hard is it to use these things? Well, basically, here I have two authors, Dave Thomas and Andy Hunt, who wrote the Programming Ruby book. And if I want to create two authors, there you go, create the book. And then if I want to add these guys to these books, I just do that. And basically, I can then look at the books. This map is very convenient. Just like any other enumerable, I can map over these. Nice little syntax for being able to pass in something as a method. So this is going to just give you the title of these books. So I'm going to say, OK, Dave Thomas, map, and Andy Hunt, and they both give the same title. And what it's doing is it's generating this thing underneath the covers. So select star from books, inner join author books on books.id equals author books.id, where author books.author ID is equal to 5. That's actually for the second one. So basically, you're generating this SQL underneath the covers whenever you do that. And, yeah, sure, go ahead. Excuse me?
So where you do DT books map title, right? Could you just say B there as opposed to programming Ruby? Or are these things different?
Well, these are the books that Dave Thomas has. So what I'm doing is I'm asking for all the books. I should have put more books in here, but basically, if I have more books, the DT books would be, yeah, it would list out all the different books for Dave Thomas. And if I did the AH books, it would just list out the books for Andy Hunt, because it's going to select all these where the author ID is equal to 5. So it's going to get all those books just for that one author. So it makes it very easy to manage these relationships. And this is actually transactional. When I do the dt.books, if dt is already saved in the database, it'll immediately insert this relationship in the database as well. So I don't have to do dt.save. I don't have to do any more manipulation on these things. I can just add it in there right away. As well, if I wanted to, I could, if DT was not saved, and I appended a whole bunch of things to it, it would just sort of queue up those inserts. And then when you saved the author, it would then go ahead and save all the associated relations as well. So there are ways, there's also some other optimizations you can do. But basically, it tries to make it so that you don't have to think too much when you're doing this. Now, we talked a little bit about this optimization of the :include. And now we want to find all the authors and include the books. So we're going to pre-populate that books association. And this is the fun little piece of SQL that we generate out the back of this thing. If you were going to actually put this into into your like Coca SQL or anything else, you would see that you get this very, very wide set of results with multiple repetitions. Nice thing about Rails is that it actually handles all that stuff for you. So it takes instances of author and knows that there's going to be multiple instances of book for each author, and it gives you one instance of author, and then it knows how to combine up the rest of those rest of those results as lists of books. Does all that, instantiates those objects, pre-populates that association. That way, this thing goes much faster, and you really, it's a standard optimization. When you start to find that applications are going a bit slow, you can just say, okay, fine, it looks like you're doing a lot of nested query, redundant queries. Let's see if we just add a couple of includes in there, get things going much faster. So next thing I'm going to bring up, so now we know basically has and belongs to many. Has and belongs to many is kind of simple, but often when you have a join model, the join model wants to contain some additional information. Here, I'm just putting a royalty amount or a percentage in there as for each author, so that each author's relationship to a book also contains a royalty. You can put any other information you want to associated with that relationship. And the has and belongs to many relationship basically is declared like this. You has many authors' books. That thing up there basically tells it about this relationship right here, that there's a relationship table. I have many of these because, remember, this is a belongs to. So we have many books, authors' books. We also then has many books through authors' books. That through is where all the magic happens. Basically, Rails uses tons of conventions to be able to know that we're looking for something that has many books. So it knows about this relationship over here. It knows that we're going through this class right here. It knows that there's a table in the middle. And it knows that basically we're going to be traversing that whenever we do a relationship. Same thing for the other side. I can say has many authors' books and authors through authors' books. And it'll all just kind of magically work. And you can configure this if you don't follow all the conventions. But if you can follow the conventions, this is about all you have to do. The join model for this, the model change is basically here. So I'm going to go through. This is a slightly more complicated migration. So because we've already got the author's books in there, and it's a simple join model, now we want to create a join, it's just a join table with just an author ID and a book ID. We want to create a join model. But we can't do that. We can't just like insert a ID column in there, which is auto increment, and have it all kind of magically work, because it doesn't work that way. MySQL won't let you do it. So basically what you got to do is create a new table. So we're going to create a table called authors books and two, and then we're going to create the columns that we want. This has an ID column because I didn't say ID false. And then we're going to execute this piece of SQL, which you see right here, because active record migration execute works on that database. And I just say insert into authors books 2, author ID, book ID, royalty, select from there. And then I have all the values populated, and I put 0.0 to default the royalty column. And then I just say drop the old table, and then I just rename this table. These are just these nice little macro-y type things, these metaprogramming things, drop table and rename table, and that now I'm done. And the reverse of this is basically I recreate the join table and then invert this guy and then do this swap again. So the down would be exactly the same, but it didn't fit on the page. Now I want to add some royalties. So now we have basically these, now we have this royalty column in the new table. And what I want to do is find this book Programming Ruby, and I want to find all the authors in the book. So basically I can say the book, authors, books, dot find. Maybe I should have called that something like royalties, but whatever. Find all, include the author, and I say the royalty equals, if the author name is Dave Thomas, 7, or else 3. I pick some numbers. 70% and 30%, or 7%, 30%, whatever. And then that will save all those values. And then if we look at, let's say, OK, here's another thing we can do. On any relationship, like authors' books, we can say we want to order them by something. So instead of having to specify every single time I do authors' books, I want to order these columns by something. Basically, I can say right here, I want to always order this relationship by the royalty descending. Also, on the has many through, I can do the same thing. I can say order these things by the royalty descending. And then if I find books by title, this gives me my books, and I do authors map name, and basically this gives me 2 authors, Dave Thomas, Andy Hunt. And then I go ahead and I say give me the books, and then authors. This is actually authors underscore books, but it doesn't come out here very well. Give me the royalty. It will list me the royalty, and those numbers will be descending because of that statement right there. If I change it around to ascending, it would flip the order, which makes it easy to create, not have to repeat a lot of code where you always want to get stuff in the same order. And you find it irritating. Anyway, so that's the basics of the 3 types of relationships that you'll be using the most. Basically, there's also a has one. Has one is where it's like a has many, but there's only a one-to-one relationship. Belongs to is where I have the ID for you and I belong to you. So I have your ID. A has many is where you have an ID pointing back to my table. And a has one is where you have an ID pointing back to my table, but there's only ever one object in there. Yes, so that's the assumption. So let's go. Rails supports a thing called single table inheritance. This is a object modeling concept inside of Rails that allows you to create an abstraction where you have a base class, and then you have subclasses, and the subclasses have slightly different behaviors than the base class. So we're just going to do a little employee thing here. I have a people table with an ID, name, employee number, manager ID, department ID, social security number, and company ID. The one thing you got to remember when you do single table inheritance is that your table that this thing is based on is always going to have to contain the superset of all the columns required for all your subclasses, because it's single table inheritance. So you're inheriting from a single table. So we have here a person. Person is sort of an abstract here, maps to people. The person, this class name at the root of this hierarchy, which is the subclassed off of active record base, is going to be the thing that determines the name of this table. The convention is take that name from that class and pluralize it. Now you have this name. We then have an employee, which is a subclass of person. An employee belongs to a manager and belongs to a department. A manager is an employee, so he has a manager and a department as well, but he also has many employees. And then we have a consultant, which is also a person, and he belongs to a company. So consultants don't belong to managers. They belong to companies. And I'm a consultant, so there you go. So here we got 3. We have an employee, and a manager, and a consultant. And we can just create this relationship here. We can say that Bob's manager is Mary, and say Bob. And then if we say Mary.employees map, we get the one name of the employee. So there we can use a relationship again and get that name out. These guys are magical. Map, find, all those methods to basically give you the latest information from the database. And then populate this. If it isn't already populated, it will be populated when those methods are called. Let's create another manager called Jane. And let's take the managers and find just all of our managers. And so we do manager.find, not employee, but just manager.find. We know we have 2 managers here. We look at Jane's employees. She's got no employees. Let's take Bob and make his manager Jane. And then Jane employees. OK, here we have Bob in there. Now if we look at all the employees, we get Bob, Mary, and Jane. Why is that? Because managers are also employees. So it's going to pick up the fact that the employee, the type of the employee can be either an employee or a manager. And now if we go to person, the most abstract, we get Bob, Mary, Jane, Tim. Tim, who's a consultant, also appears now as a person, but not as a manager or employee. So it basically is handling all that class hierarchy relationship stuff for you automatically. The magic of this is in a column here called type. In any class, actually type is, unless you override it, type is always assumed to indicate that the table is supporting single table inheritance. So if you use type as a column name, be aware that you may need to set the single column inheritance name to be something else, because Rails may start to do something funky on you. But type basically is a class name that thing is associated with. So basically, for a manager, type is going to be equal to manager. For an employee, type is going to be employee and consultant and so forth. And if you look at the SQL that's generated from this thing, you'll see that it says, when I did this employee.find, it's going to say select star from people where type in employee, comma, or I think it does a type equals employee or manager. So it expands that out for you automatically. It knows about the class hierarchy, and you don't have to do anything. It's very handy. So that's the type of class hierarchy that's supported within Rails by Active Record natively. The other thing we can do is, let's say you don't want to do a strict hierarchy, but you want to have a relationship that goes to some other resource. And this resource is just something like this is, let's say, a CMS. And you want to have video, text, and image content within it. And you have this resource. There's this nice little thing that you can say is that this belongs to a polymorphic resource. And here we have a resource table. The name isn't important there, but this is. That name here, resource, resource ID, resource type, basically maps to that thing. And then what this will do is it will look at the type, and whatever this type is, it will know that it has to go to that class type. So if this type happens to be video, it will go to video. This type happens to be image, it will go to image. Or text content, it will go to the text. And then with the ID, it will map to any one of those records. So basically, you can have this free-form network of objects where you can refer to many different types. This is very useful when you're dealing with things like CMS, which have not just hierarchical information, but want to relate a single set of content for a page with various different bits and pieces that will fill in the content for that page. The other thing that Active Record provides for you is some simple calculations. So for computed results, standard stuff that you get from SQL, you get maximum, minimum, average, sum, and count. And pretty easy to deal with. Basically, if you want to get the average price of all the books, you can just say book.average : price, and that will give you all the prices. If you want to find out how many books you got, do book.count. You can also provide things like conditions and halving, and as well to be able to filter. And also you can do things like grouping. So if I want to say books maximum price for each group, and you have a category column, you can group by category, and then we can return the maximum price, or you can do average price, whatever. This will give you an array of arrays, where the first value is the grouping value, and the second value is the aggregated value. Counting is a little bit special. Counting, if it's given one argument, it's automatically taken to be conditioned. So this is basically the same as Armando was showing you before. We can say, you know, book.count price is greater than price, and that will be the number of books. The other thing we can do is add additional joins in there. So we can do like a left join author's books on book ID is equal to book ID or whatever. And we can basically create a join which will give us a number of books that match also this join condition as well. And then you can also do this thing count by SQL, where you can actually put the SQL statement in there directly. As long as it does a count star or a count column, it will work as well. So there's a way to do it the hard way, and then there's easier ways of doing it. And this gives you most of the flexibility you need to be able to do most things you want to do. Now, we mentioned transactions before. I just wanted to show you. There is a transactional model. You can actually do transactions on multiple databases. Rails supports a database connection per class. So if I had multiple databases in back of this system, I could actually have one class mapped to one database, another class mapped to another database. Let's do a simple situation first. So an author, this is saying author, create a transaction. These two objects I pass in here, author 1 and author 2, are related, and basically what I'm saying is, okay, we're going to try to append this book to these two authors. So we're going to change this books. It's going to, again, change that join table. And then at the end of this thing, it auto-commits. If an exception is thrown during this process, it'll automatically roll back the transaction for you. You don't have to do anything. The other nice thing it does automatically for you is these two authors here, they'll also get automatically rolled back within your application. So I don't have to do anything. Basically, the transaction fails. These guys are back to their original state without those books. So it's really convenient, and I can do nested transactions as well, where I can put one transaction inside of another transaction if I want to do like multi-table or multi-database commits. There are some issues because it doesn't really have a full two-phase where you're doing a prepare and commit phase, but it'll give you a little bit of assurance that at least one of the databases will be in the right state. The one on the outer may or may not. So what else can we do with Active Record? Active Record has this nice concept called aggregations or composition. Sometimes you have a column or a set of columns that are related inside of the database. And here we have something called an amount or a price. And let's say the price has a certain currency associated with it. But every time you deal with the price, you don't want to have to know about the currency. So you want to So we can wrap it in this object. We have an object called money. It has an accessor on it where it can get the amount and the currency. We'll also have a convert to a new currency, and we'll have some way of getting the rate from some feed or something and then being able to multiply out the rate. And the constructor is pretty simple. It just sets the amount to the amount and the currency to the currency. And then we can say here in Active Record, we say that the price column is composed of a money class. And the mapping is the amount maps to the amount, and the currency maps to the currency. So the columns in the database are amount and currency, and those map to this guy here, amount and currency. And you get a composite field called price. To use that, we can create a new money object like that, money, and $29.95 in US dollar, and put that in price. And then if I do a book.create, title, whatever, and the price assigned to that object, it will take it, and it'll know how to map the columns from, or the instance variables from price back into the price object, or into those two fields, the amount and currency, inside of the book, and do everything correctly. As well, if I find the book, I can then get the price out of the book the same way. By book.price, it's sort of a pseudo column. If I say price.amount, it's going to give me $29.95, and then I can say, like, convert that price to euros, and it'll give me 22.02. So it's a nice way of being able to wrap if you have complex objects, you can wrap a number of database columns within a single object and put some extra functionality on top of it, like price. You can do automatic conversions. There's a lot of other things you can do as well. Yeah, sure, go ahead.
You said it was defined as a dollar amount in the database?
No, it's because it was this composed of down here basically says that the price, this pseudo price column, is composed of a money class that maps to the amount in the currency from the database. And this order is the order of the arguments within that constructor. So another nice pattern that Active Record gives you is the ability to add what's called counter caching. Counter caching is commonly used, especially in web applications, where you want to know how many of something somebody has without having to do a select count. Because often that takes a lot of time when you have a web page and you want to know how many tags are associated with a particular item, or you want to know how many books are associated with a particular author in this case. So we want to be able to add a column to the authors table. This is a snippet from the migration, authors, books, counts. And then basically it's an integer. It defaults to 0. With a counter cache, one thing to remember, always put the default 0 in there. The semantics of this is basically the table name, authors underscore books underscore count. That's the convention. And remember how we defined this record here. So if I'd say belongs to author, and I say counter cache true, and I say Dave Thomas, and I say book create, another book Agile Rails 2, and I say Dave Thomas reload, and I then reload is a method in Active Rails, which is very handy. Basically, if you have a local object and you want to reset its state from the database, you can just call reload on it, and it will reset its state from the database. Then I can say dt.books == b, and then if I ask for the author's books count, it'll give me 1. And then let's say I find another book, and here I again do the dt.books == b2. And again, I reload this guy to be able to refresh that thing. It'll give me 2. So what this does, it's automatically updating that counter cache column, the author's books count, for me without me having to do any work. Whenever I adjust this relationship between the two, whenever I update this books association.
I'm not getting in the first half of that example. You
Yeah.
reloaded, and then you added the book. In the second half, you added the book, and then you did the reload. Why is the order different?
Because I may not have even had to do the reload. Actually, because this refreshed, let's see, I probably should have reversed these two. You're right. I would have added it and then reloaded it. Something got reversed in the example. It's either that or it just worked. I probably may not have even needed the reload. I thought I needed the reload because I would have to refresh that from the database, but it might have automatically done it when this happened.
Question.
Yeah.
There's so many ways to be creative with the names of the methods, by matching the names of items in the database, columns in the database, that kind of thing.
Mm-hmm.
Is there any IDE that's been created that has IntelliSense or any way to automatically show you the options you have for while you're typing?
There are a couple of IDEs for Rails. I find that most of the time I really don't need an IDE because, like for these methods here, find by title and find by whatever, it's basically just the names of your columns. So that you're not, the method name itself is just find. If you just remember find, and then just find by, and then whatever that column name is. So if it's title, name, birthday, address, it's not very complicated.
It did seem like there were a few places where if you didn't know about a convention, you could get screwed. Like convention type, where there was the example that Armando had with the UCB ID, and he had to change it to UCB_SID. So if you're unaware of conventions, you may sort of stumble over them inadvertently.
You may, yeah. And type is one of them people stumble over. And IDs are another one.
Like
Yeah.
protecting sugar, like you say,
Mm-hmm.
often maybe didn't know about shortcuts.
Yeah. and you kind of learn them as you go along. Sometimes if you just stick to sort of the simplest to start out with, and then you sort of learn shortcuts. Things like the find by. I mean, you could do this all just using the find, and then colon, let's say first, comma, conditions, title equals question mark, comma, whatever, programming Ruby.
Like debugging this stuff must be quite a nightmare.
Actually, I don't.
That type example, if you were to do that wrong, and you were trying to figure out why you're getting some mysterious behavior. I mean, it's the kind of thing I can imagine pulling my hair out for a long time trying to figure it out.
Yeah, debugging I haven't had too much trouble. There's actually there is debugging built into it. And there's even you can set breakpoints within the application. I don't know if Armando, are you gonna get into that at all?
Into
Debugger?
which?
The debugger?
I don't think there's going to be time.
Okay. There's a way to be able to do that within the Rails application, to be able to set breakpoints within the controller and then dynamically just jump in there, stop the application, jump in there, and look at all the instance variables and sort of poke around and then come back out. I find that personally, I tend to just either use command line tools like the console. If you have an application up and running, you can just use the console, pop that up, and explore the database, and explore Active Record, and try things out and see if they work. The other thing you can do is sometimes as simple as just logging helps. You can log to the log file, and that will tell you what happened. You get full backtrace whenever an exception occurs. For conventions, why things don't work. Sometimes, it is irritating, but I find all frameworks so far that I've used are equally irritating in that way. So, I've done some in JSP. I find it's not any easier to figure out why your tag helper isn't getting invoked properly because you haven't configured the XML correctly to tie it in. So, there's always going to be that issue. I find it's not that bad, but it's probably also because I know what's going on. So, next thing I want to talk about a little bit, you have all these additional, all these other, I would call them almost helpers, but they're basically acts as. There's a lot of these things. I'll just go through a couple of them. You can tell a class that's going to act as another type. Access trees, nested sets. You can say solar. You can do a whole bunch of different things inside of Rails, where it's pretty straightforward. Okay, so here we have a table. Again, we're going to do the migration. We have a simple table called groups. It's hierarchical. It has a name and it's a parent ID. It's very simplistic. And we want to say that this group acts as a tree. And the order is always going to be name. And it's going to create a parent-child relationship. So that's all I have to do to create a tree structured class. And basically here I create my root class called root. If I want to, I can add children to this group by just saying root.children.create, name child 1, child 2, and so forth. I can just create the whole tree that way. It's going to fill in all the IDs for me. The children are automatically going to be created relations, similar to the way we did the has many. And so it's basically, there's an automatic belongs to relationship to the parent, and then there's a has many relationship to the children called children.
The difference here is that the ID references are within the same table as opposed to.
Yeah, it's one of these fun recursive joins. This is not the optimal way of doing this, because if you really want to do a tree, this is regardless of whether you're doing Rails or any other framework, you want to use nested sets. They're a hell of a lot faster. There's some nested set acts as implementations for Rails. There's acts as nested set. There's also better acts as nested set, which is actually a bit better, and supports multi-rooted trees. So it's a much more efficient way of being able to get sets out. If you want to learn more about that, I can tell you about later. Yeah.
Question, right? This is a more general question on Rails side.
Uh-huh.
How do you use access tree versus single table inheritance?
No, this is not inherited. This is basically, I have in the table I have a bunch of groups. Like, I have my root group, and then I have a whole bunch of child groups. This isn't an inheritance hierarchy. If I wanted to if I wanted to create an inheritance hierarchy as a relational data set, this is the way I do it. So if I wanted to create a table called, let's say, my classes, I could then instantiate, my class.create person, and then my class, then person dot children, create, employees, so forth. So this is basically just, it's a hierarchy that exists in the database. And relational databases kind of suck at this stuff. So the other thing that's common, another common pattern is a list. So we have an ordered list of items. Because the order of the items may not always be what you want it to be as they're inserted into the database, we have this thing called AJAX as list. So here we have a thing called thumbnails, and it has a file name and a picture ID and a position. The position is kind of a magic column. You can overwrite the name of that thing, but that's going to be your position within the list. So then we have a thumbnail, belongs to a picture, acts as a list. The scope is going to be within a picture, so I have a picture that has multiple thumbnails of different file formats. I can add these in there, and then I can give them an order. So if I do picture.thumbnails create, it's going to create these guys. And then what I can do is I can lower them. I can move them around. So I can say, the first thumbnail, I want to move that down. I can move a thumbnail to the top. One of the places you see this often is in AJAX. So if you've ever seen some of the UIs where you have like drag and drop, you have a drag and drop list. There's actually something that ties directly into this from the UI where you can create an AJAX drag and drop list, and as you reorder the images around, it'll call back in, and that list will then reorder these objects automatically. You can just kind of throw that reordering back into Active Record, and it just kind of does all the magic for you, and suddenly the list comes out the right way. So I'm kind of try to wrap up a little bit here and tell you where things are going. So we've talked a lot about Active Record, and Active Record is actually just a persistence scheme. It's a model that persists on a database. But there's nothing to say that all models have to persist on a database. And there's this movement in the next, it's probably going to come up in the next couple of releases of Rails, but in general, if you can CRUD it, you can make it into a model. Basically, if it can create, read, update, and delete, then you should be able to turn it into a model. And there's a pretty good RESTful support inside of Rails, representational state transfer, which basically means that URIs represent a resource on the internet or somewhere, and that URI can then be taken through a series of state transitions and through various calls just straight through with the CRUD type syntax. And HTTP supports it. Get is basically your read. You have post, put. The post being new, put being update, and delete. So you can operate on almost any resource if it supports a RESTful API out there on the internet. And they're going to try to wrap, I think, the web services back into the whole model layer. So your web service will also become a resource, a model resource. So you can start thinking about models in a more abstract way. Models don't just happen to be a database persistent thing, but it's a more general purpose thing. It's whatever contains your business logic. It could be a resource that's out there on the internet. It could be something that persists on your database. It could be whatever you want it to be. And actually, even in Rails, if you can make a model that's not descended from Active Record if you want to, as long as it has that sort of duck typing behavior, it'll work fine. There's also some other backends that are coming out for Rails. There's some ontological databases which are coming out. Things like there's DataGrid, which is a new product that's being released sometime, and they're just sort of in the alpha stage. S3, there's been somebody talked about doing an S3 adapter for Rails as well. Solar, Ferret. For full text search engines, there's AJAX as Solar, but you can use Solar as a backend as well, model that thing. So there's some different ways you can be able to store your information. Don't have to stick to a pure relational model. The guys over at Joyent say that you should go for something different, but they're even suggesting flat files at this point. That's, I think, because of Twitter's load. So that's pretty much what I was going to cover. Are there any questions?
We're almost back on schedule.
I know, I was trying to go fast. Hopefully not too
Okay.
fast.
Cool. Well, we'll take a short break, and then I want to ask Will a question because something isn't working that I think should be, and it'd be cool if I could demonstrate it.